Hi guys, and welcome back. Mr. G once again here. Previously, I left you with this exercise to go measure the sides and the angle. And I hope you have faithfully done that and compared the sides. And one of the things that you would have figured out is that actually these ratios here are what are the same, okay? In other words, the ratio that you've got here and the one that you've got there and the one that you've got there are actually equal. I forgot to mention, yeah, it would be a good idea to actually round off everything to 2 decimal places. That will be quite good. Now, from grade 9, what can you say about the following triangles? What can you say about triangle ABC? What can you say about triangle KLM? And what can you say? Oh, I think I had an M here. And can you say? So actually, this is supposed to be an N, okay? That's supposed to be an N, yeah. My bad. So that's supposed to be an N. So what can you say about triangle KL? Actually, it should not be even N. This should rather be C because KLMN is a quadrilateral, not a triangle. So what can you say about triangle ABC? What can you say about triangle KLC? And what can you say about triangle MNC? Well, I hope this word came to you or to your mind. The triangles are similar. And that is actually where trigonometry comes from. Okay? Trigonometry comes from similar triangles. It's all about similar triangles. Now, I want you to do something in your calculator. I want you to try and do this. Let us assume that theta is 30. Okay? So I want you to press for me cos 30. Okay? And because I have an idea of what that should be, I'll put up there something like square root of 3 over 2. So I hope you are doing that. And that means somehow you guys should have obtained something like 0.87. Let's leave it at that. You obtained something like that. If the experiment went quite good. So you realize that if you did everything well, that the ratios are the same. That's number one. Number two, cosine of this angle is actually equal to the ratio that you have put up. There's a nice exercise that actually is best to help you understand trigonometry as we go along. So what I want you to get now from this whole thing, especially after introducing 30 then, is that the ratios are actually independent, okay, of the angle, but they depend on the fact that triangles are similar. Now, I'm sure you are asking yourself, but which ratios are you talking about? Well, in trigonometry, there are three basic ratios that we are going to start with, okay? So maybe I should write in here trig ratios. One is the sine, written as sine in full, but we also write it as sine, S-I-N. It is not sin, it's sine, even when it is written like this. We also have the cosine, which we write as cos, as you have seen there. I asked you to do that. And the third one is the tangent, okay? You'll get a better picture of this whole thing in the upcoming videos, and we usually write 10. But I'm sure you have seen these buttons in your calculator. You've probably asked yourself, where do they come from and all that. Now, welcome. We are just gradually stepping into the big world where you can be able to use most of the buttons in your calculator. So that's one thing that I want you to get from this exercise. It is very critical, crucial for your understanding of geometry. Now, guys, let us take any arbitrary a right angle triangle. Okay, let us take any arbitrary right angle triangle. I don't like this, so I'm gonna take actually the text option. I mean this nice one here, where I can put up a nice triangle. Yes, this is more like it, and there we are. And as I indicated, you guys should assume, not assume, but you should know that this is a right angle triangle. And I'm gonna put up my theta down here. There's my theta, and I'm going to define a number of things here. Let's suppose this is A again, and this is B, and that is C. The side which is opposite to the angle theta, we call that side opposite. And you will see more often I will write op for shorthand. The lazy mathematician again. We don't like writing. That's why we've got a lot of symbols in mathematics. Now the side which is like on a walking path relative to my angle, we just call that the adjacent, and I'll just say ADJ. I will not even mark you wrong if you put this for me, because that's how we roll in mathematics. And the longest side is the hypotenuse, and I'll just write height, okay, or H, okay. This we can also say A, that you can also say, call it Y, sorry, not Y. You will see why I wrote Y actually. You can call it O for now, that H for now, that A for now, okay? You can just call it like that for now. Now, what I want you to understand is that now from that little exercise we had, we can actually write the following ratios. I can have the ratio that says A over H, meaning of opposite over hypotenuse. I can also have a ratio adjacent over hypotenuse, which is the one that you actually did a little experiment with and you didn't realize, and now you realize. And I can also have a ratio that says opposite over adjacent. When we get really crazy and complicated, I can have a ratio also called hypotenuse over opposite, or hypotenuse over adjacent, or adjacent over opposite. What I want you to understand is that all these ratios actually depend on the angle theta. That is the very critical and important thing that you need to get out of this. Now, I'm going to pause here because I do not want to weary you with these long videos. In case you want to take a break, the time it is now. When we come back, we are flying. I'm going to move on now nicely to introduce the other things. The note from this is that these ratios depend or rely on the angle theta. The interesting thing is that when we did the little experiment, we saw that in any triangle, actually, somehow the ratios are the same. And they are the same because they depend on one and the same angle, in this case being the angle theta. I'll catch you guys later. You may go drink water or something, but we continue in the next video.